Model Context Protocol just crossed 97 million monthly downloads. And Anthropic, the company that built it, just gave it away. If you watched my MCP explained video, you already know the basics. Quick recap for anyone new. MCP is the protocol that lets an AI model actually reach out and use things, your files, your calendar, a database, another piece of software, instead of just generating text and hoping you copy-paste it somewhere useful. Think of it as the wiring between a language model's brain and the outside world. Under the hood, it's simpler than people assume. There are three players: a host, which is the app you're actually using, like Claude or ChatGPT, a client, which lives inside that host and manages one connection, and a server, which is the piece exposing a specific capability, your Google Drive, a code repository, a weather feed. And servers only ever offer three kinds of things: tools, which are actions the model can trigger, like sending an email; resources, which are data the model can read, like a file or a database record; and prompts, which are pre-written templates a person can pull up to kick off a task. That's the entire vocabulary. It's deliberately boring, and that's exactly why it scaled. Here's what's changed since that video. MCP launched in November 2024 with roughly 2 million monthly SDK downloads, a modest, interesting idea from one AI lab. By March of 2026, that number had crossed 97 million. That's a 4,700% increase in 16 months. For comparison, Kubernetes, now considered the backbone of modern cloud infrastructure, took nearly 4 years to reach a comparable adoption curve. React, the most widely used JavaScript framework ever built, took about 3 years. MCP did what both of those took years to do, in a year and a half. And on December 9, 2025, Anthropic made a move most companies don't make with something this valuable. They donated it. MCP now belongs to something called the Agentic AI Foundation, a directed fund under the Linux Foundation, the same nonprofit that stewards the Linux kernel, Kubernetes, Node.js, and PyTorch. Anthropic co-founded this new foundation alongside Block and OpenAI, with Google and Microsoft also backing it. This isn't just a paper protocol anymore either. Block, Bloomberg, and hundreds of Fortune 500 companies are running MCP servers in actual production right now, and one market analysis projects the ecosystem growing from roughly $1.2 billion to $4.5 billion in just a few years. Why does the governance change matter, practically? Before this, any enterprise evaluating MCP had a reasonable hesitation. What happens if Anthropic changes priorities, gets acquired, or just decides to pivot the spec? Handing governance to a neutral nonprofit with decades of track record answers that question directly. MCP isn't one company's protocol anymore. It's shared infrastructure, governed by committee, the same way the technology under half the internet already is. Now, here's the part that actually matters for you. Whether you build with AI or just use it, what MCP actually does, and whether you need it at all. Start with the obvious question. APIs already exist. They've existed for decades. Every app on your phone talks to a server through an API. So why did the entire AI industry suddenly need a new protocol on top of that? Here's the honest answer. A traditional API is built for a human developer who already knows exactly what they want. You read the documentation once, you write code that calls 3 or 4 specific endpoints, and that code runs the same way every single time. It's deterministic, it's predictable. It's also completely rigid. If you want to add a 5th capability, a developer has to go back and write more code. An AI agent doesn't work that way. It doesn't know in advance which tool it'll need. It might need to check your calendar, then search a database, then send an email, and the exact sequence depends on what you actually asked for, decided in real time. Point a language model at a company's internal API with 75 or 100 endpoints, and it genuinely struggles. Language models are surprisingly bad at picking the right option out of a huge list. They slow down, mix up similar-sounding endpoints, and burn effort on options they'll never use. MCP's actual innovation isn't the connection itself. Most MCP servers are just wrappers around ordinary REST APIs underneath. What MCP adds is a standard way for a model to discover what tools exist, understand what each one does, and decide which to call, all at runtime, without a developer hard-coding the decision tree in advance. People call it the USB-C for AI, one standard plug, instead of a different custom adapter for every single tool. That's the pitch. Now here's the pushback, and it's a real one, not a straw man. In March of 2026, Perplexity's CTO, Dennis Uratz, announced publicly that Perplexity was moving away from MCP. His stated reason: MCP tool definitions were eating up 72% of their context window before the model even started working. An independent analysis from a company called ScaleKit backed that up. finding MCP can cost 4 to 32 times more tokens than just calling the same functionality through a direct command line tool. Within days, MCP is dead was trending across developer forums. That criticism is legitimate for a specific situation. If you're a solo developer building a coding agent that talks to one service through a handful of known functions, wrapping that in MCP adds real overhead for basically no benefit. You already know what you need. A direct call is faster, cheaper, and easier to debug. But that criticism misses the situation MCP was actually built for. One team building a company found that loading 916 possible tools into an agent's context directly was useless. The agent got confused and picked the wrong one constantly. Their fix wasn't to abandon MCP. It was to make the agent search for relevant tools first, then only load the 5 or 10 that actually mattered, a 96% reduction in token overhead, while keeping the flexibility MCP provides. The pattern that's actually held up: use a direct API when you're calling one service through fixed, known endpoints. Use MCP when an agent needs to discover tools on the fly, chain several together, or work across many different services it wasn't specifically coded for in advance. There's a newer fix for the token bloat problem too, and it's worth knowing about. It's sometimes called code mode, or programmatic tool calling. Instead of the model burning one full inference turn per tool call, going back and forth, it writes a single script that runs in a sandbox where every connected MCP server just looks like a normal function it can call in code. One turn, one script, however many tools it needs inside it. That single change alone recovers most of the efficiency the critics were complaining about, without giving up the flexibility that made people want MCP in the first place. While we're talking protocols, it's worth clearing up a confusion I see constantly in the comments on my A2A video. MCP and A2A are not competitors, and they're not the same thing. MCP connects one agent to tools and data, an agent talking down to a resource. A2A, agent-to-agent protocol, connects one agent to another agent, a peer talking sideways to another peer that might specialize in something completely different. A travel planning agent might use MCP to check a flight database, then use A2A to hand off booking to a separate payments agent it doesn't control. Different layer, different job, and increasingly, real systems need both. There's also a security dimension to all of this that doesn't get enough attention. Giving a model the ability to discover and call tools on its own creates a genuinely new attack surface. Researchers tracking MCP vulnerabilities have found that a large share of the security issues, over 40% by one count, trace back to something depressingly familiar: developers passing user input straight into a shell command without sanitizing it first. The same class of bug that's plagued software for decades, just wearing a new AI costume. That's not a flaw unique to MCP the protocol, it's a flaw in specific implementations of it. But it's exactly why the newest spec revisions lean so heavily into OAuth 2.1 and tighter authorization, so an agent only ever gets the exact permissions it's supposed to have, for the exact user it's acting on behalf of. There's an even more recent twist to this story, and it's a genuinely great illustration of how fast this whole field moves. Just 2 weeks before this video, on July 28, 2026, MCP shipped its biggest specification change since launch, and it makes the protocol stateless. Previously, connecting to a remote MCP server meant a whole handshake. The client and server would exchange session information, the server would hand back a session ID, and every future request had to land on that exact same server process. At small scale, fine. At enterprise scale, it was a nightmare. You needed sticky load balancing, a shared database just to track sessions, and gateways doing deep inspection of every request just to figure out what it even was. The new spec strips all of that out. Every request now just carries what it needs: protocol version, client identity, the specific tool being called, right in the headers, the same way a normal web request works. Any server can now handle any request. Standard load balancers work, standard caching works. And this is where the debate got interesting. Some developers looked at this change and said, out loud, "Doesn't this just turn MCP into a regular REST API again?" One commenter put it bluntly: "We invented a stateful protocol, discovered state doesn't scale, ripped the state back out, and arrived at just send a post request, and the REST crowd had been smugly waiting 20 years for exactly this moment." The counter-argument is worth hearing too. MCP was never really about the transport mechanism underneath. It's JSON RPC over HTTP, nothing exotic. What MCP actually provides is the shared vocabulary. Every AI provider agreed to describe tools, resources, and permissions the same way, which is precisely why a tool built for Claude also works in ChatGPT, Cursor, and half a dozen other clients without anyone rewriting it. That agreement, not the wire format, is the part that was genuinely hard to get an entire industry to do, and it's the part that survives this change completely intact. So, pulling all of that together, do you actually need MCP? If you're a solo developer building one agent that talks to one service through a handful of endpoints you already know by heart, honestly, no. A direct API call will be faster, cheaper on tokens, and easier to debug when something breaks. MCP adds a layer of indirection you don't need yet. If you're building something that has to discover unknown tools at runtime, orchestrate across many different services, or needs to work the same way across multiple AI platforms without you rebuilding the integration for each one, that's exactly the problem MCP was designed to solve. And at this point, with 97 million downloads, Linux Foundation governance, and native support in Claude, ChatGPT, Gemini, Copilot, and Cursor, it's not a bet on unproven technology anymore. It's closer to the safe default. APIs and MCP were never really competing with each other. APIs are the foundation, the actual pipes that move data. MCP is the layer sitting on top that lets a model figure out which pipes to use and in what order, without a human deciding that in advance for every possible situation. Build the right thing at the right layer, and you get an agent that can genuinely reason across your tools, instead of a hard-coded script pretending to. Every source for this video, the Anthropic governance announcement, the download numbers, the Perplexity and ScaleKit analysis, and the new Stateless Spec, is linked below. Subscribe if you want the next piece of this story, because at the rate this protocol is moving, there probably will be one within the month.